So hopefully by now you've worked through factoring with decomposition and you got a little bit of kind of a better handle on it right now. And again, please ask questions if there's anything that you need. And I did promise you that that was the hardest factoring that we do in grade 10. And we do have one more factoring lesson, factoring quadratics when we have perfect squares. And I promise that this one is much easier. We're going to go back to kind of one-step thinking here. Maybe 2, not 4 or 5. So first thing we need to do is we need to remember what a perfect square is. And I made a list of perfect squares here across the top of your page. We have a poster of them in the classroom for you to look at and refer to when we're in the classroom. But for now, we want to maybe just have a piece of paper and some notes that kind of remind us what our perfect squares are. So just remember that, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. These are, and the results of that are our perfect squares. So these are our perfect squares. Okay, so if we're going to factor, we're going to look for 2 different kinds of quadratics. Again, there's that word, quadratics, that have perfect squares. And not every number needs to be a perfect square. So just 2 of them in specific need to be perfect squares. So there's 2 different kinds, and these usually we don't need to worry too much about the labels we give things in math, but I do want you to know the names of these. I want you to know what a perfect square trinomial is, and I'd like you to know what a difference of squares is. Especially difference of squares, they pop up kind of all over the place, and we want to be able to recognize them, and we want to be able to give them a name. So perfect square trinomials come in this form: ax squared plus bx plus c, which looks familiar, but a and c are perfect squares. Okay, perfect, not prefect, perfect. All right, sorry about that. All right, so we've got A is a perfect square and C is a perfect square. Don't forget that 1 is a perfect square. Okay, now our second kind of quadratic that we can use perfect squares to factor is called a difference of squares. And I hope you remember that a difference is the answer to subtraction. So this implies that there's going to be subtraction involved, and that's exactly what we have. We have ax squared minus c, and there's no b term here, right? There is a b term, it just has a value of 0, so we don't write it. Okay, we don't write terms that have a coefficient of 0 on them. So but a and c are perfect squares, which means that we can factor these guys. All right, let's take a look at the first one here. This is a perfect square trinomial. It has 3 terms, and a is 4, c is 9. So 4 and 9 are on our list of perfect squares. This is a perfect square trinomial. And it's really easy to factor these guys. Just remember that the square root of 4 is 2, and the square root of 9 is 3. Just kind of keep that in mind. You know that. We don't even have to write that. Just think about that. And we know that when we factor a quadratic, we get 2 brackets. Now, 4x squared comes from 2x times 2x, and this 9 comes from 3 times 3. And what we need is these terms to add up to 12x. So I'm going to make sure I put pluses there. So it adds up to 12x. And some people kind of get freaked out. They're like, oh, where does the 12 go? How do I get the 12? Don't worry, it's there. If I check this by foiling, 2x times 2x is 4x squared. 2x times 3, 6x. 3 times 2x, 6x. 3 times 3. And I can combine these to 4x squared plus 12x plus 9. Okay, so when I see that I have a perfect square here and a perfect square here, I can simply just square root those guys and put them into the brackets. Okay, should be pretty straightforward. I'll give you another example here. Let's see, I'll come up with I should not have tried to come up with one on my own here. 16x squared plus 20, let's see, 40x plus 25. Okay, so here we'll do this. There's no way I would make you do this through decomposition, right? So I would never expect you to multiply 16 by 25, make a list of factors, look for the pair that adds up to 40. So because these numbers are so big, there's got to be something else going on here, and that something else is perfect squares. So when I factor this quadratic, I know I'm going to get two brackets, and 16 is a perfect square, 25 is a perfect square. You know what I'm going to do? I'm going to change this actually to a minus 40. Let's change that to a minus 40 so I can show you something else. This 16x squared comes from 4x times 4x. This 25 comes from 5 times 5. And I need my, my inside terms to add up to negative 40. So I need these to be negative 5 times negative 5. It's because 4 times 4, that's 16x squared. There's a minus 20x, a minus 20x, and a plus 25. So that's where our minus 40x comes from. So this is our final answer here. If you really want to be fancy, you can write it like that. Okay? So that's how we factor a perfect square trinomial, a term that has three, or a quadratic that has three terms, and the a and c term are perfect squares. A difference of squares looks a little bit different because it doesn't have a b term. It has a perfect square, subtract another perfect square. And these guys are, again, pretty easy to factor once we recognize the pattern. So we know when we factor this, we're going to have two brackets. Where does this 81m squared come from? Well, 81m squared is 9m times 9m, and 49 is 7 times 7. The only problem is that I need my middle terms to add up to 0. So if I make one a positive and one a negative, watch what happens when I check my work. I'll check my work, foiling. 9m times 9m is 81m squared. 9m times negative 7 is negative 63m. Positive 7 times 9m is positive 63m. And then 7 times negative 7 is minus 49. And we can see that this middle term, plus 63m and minus 63m, add up to 0 m's. So that's what happens to our middle term then. Okay, so we know we did it right. So it's just a matter of remembering those two patterns. All right, let's take a look at the very last problem on the page. Now I hope you're a little bit kind of confused for a second, because 162 and 2 are not perfect squares. So they're a good reminder that we must right? So no matter what strategy we're using, decomposition, easy way, perfect squares, difference of squares, perfect square trinomials, it doesn't matter. We must always look for a greatest common factor first. It's a really important step. And there is a greatest common factor of 2 here. And when I factor it out, I'm left with 81b squared minus 1, which looks like a a difference of squares. So we just have that 2 in front. Those darn common factors kind of mess things up, but we'll keep it in front, and then we'll do our 2 brackets. Okay, don't forget to keep the value of the 2 in your work. The square root of 81v squared is 9v, so we can put that in there. And the square root of 1 is 1. Remember, because it's a difference of squares, we need to have a plus 1 in one bracket and a minus 1 in the other bracket. And then now that's fully factored. Okay, and you can always go back and check your work anytime for these guys. And I encourage you to do that. I encourage you to foil it, whether on paper or in your head, to check your answers. Good luck, guys.